Well, today we're going to go ahead and take a look at a project and also how to identify components. It's figure 1.8 and it's an astable multi-vibrator, and it's a 555 timer that just basically flip-flops back and forth and flashes an LED. So we have the circuit hooked up on the breadboard, and the chip is a 555. It's an NE is the first two letters, and then it says 555 on it, and I'll zoom in a little bit closer on that in just a second and show you the orientation of it. But I wanted to just show the breadboard hooked up to the power source, which we're using the Arduino Uno as a 5-volt power source, and I have a ground wire that runs along the edge. There's a set of holes that are called a bus, and this is, I'm using the let's see, the way these breadboards are labeled, it says X and Y. So I'm using the X as the hot along this edge, and I'm using the Y as the ground along this edge. And the ground connects to the one hole over here, and all of the other holes are connected along this edge. So I have a capacitor negative side connected in that hole, and also in that bus is the negative of the LED. All right. On the other side, on the X side, I have my pico fuse, and I'd like everybody to use a fuse on the positive side. Doesn't really matter if it's on the positive or the negative, but just for consistency, let's put them on the positive side. And what the pico fuse is, let me go ahead and pull this out. The pico fuse is a component that has a rating, in this case, 1/2 of an amp. So it's 500 milliamps. So if the current exceeds 500 milliamps, which is the maximum that the Arduino should source, the pico fuse will blow out just like a regular fuse would, and you have to replace it. Everybody should have 3 of those in their bag parts, and they're a little bit tough to identify if you don't have good vision, but I can't really see it, but it probably says 0.5, or it might say 500 MA or something like that to identify that it's a fuse rated at that amount of current. So that's going to save us from any kind of problems if we don't have a wire in the right spot. But what I'd like everybody to do is, before you even connect it to the Arduino, make sure that all of the wiring is correct, and then double check it, or maybe have someone else double check it, if you're working in a group. But if you're working alone, just make sure that you double check everything and make completely sure that all of the wires are okay, because it's pretty easy to miss a spot and have something a little jumbled up. All right, so the way that the Arduino is set up, we have the header pins that show VN, ground, and 5 volts. And so I have the farthest ground connected to the bus that says Y, the X bus, that's the lines that run along the holes that run along the edges. The X bus I'm using is the hot. So it says VN, ground, and then 5 volts. So very carefully I'm going to go ahead and put that pico fuse back, and that's going in now from the 5-volt output of the Arduino to the bus that's going to give me power to my breadboard. And then the other side gives me my ground. All right, so what happens? Well, I double check this thing, and we have our fuse in there, so we're all safe. And now I'm going to go ahead and connect the USB connector to the computer, and that'll power the Arduino. And on the Arduino, there's a voltage regulator that's up toward the top by where the USB comes in, and that voltage regulator will provide the 5 volts to run our circuits. So I'm going to go ahead and connect up our USB connector, and what you'll see on there is the LED should flash at about 1 time per second. And the reason that it's doing that, figure 1.8, you'll see the components that we're using on the timing circuit, which are 2 47K resistors and a capacitor that's rated at 10 microfarad. So because of that time constant that we have with the RC of the resistors and the capacitor, that gives us 555 timer pulse at 1 second. If we were to change those components, we would change the frequency of the output pulse. All right, so we see that it's working okay now. I'm going to disconnect everything, and once I rip everything out of there, we're going to go ahead and rebuild it, and we'll go very, very carefully, step by step, and see how we're supposed to connect everything back up. The first thing I'd like to point out is that there's always going to be an orientation mark on the IC, and then the numbering scheme, numbers 1 through 8 in this case, are going to be laid out so that across the bottom they're going to increment up to the highest number that's possible on the bottom, and then they kind of rotate counterclockwise where you continue on the top with the remaining numbers. And this numbering scheme is true for the chip that we're going to be using, the NE555 timer, but it also follows along with any other chips, even the 14-pin chips or 16-pin chips or what have you. And you could probably see better if I could zoom in, but there's a little orientation mark, and that shows us also that the writing is normal, right side up, and that means that the standard is that this is pin 1 right here at the very bottom, and you count over for however many pins there happen to be. In this case there's 7, and then you counterclockwise come up to the top and continue counting the opposite way. So now you have from 1 through 7 on the top. Now you have 8 all the way up to 14, and usually on the digital chips, almost without exception, on the digital chips, the lower bottom right is ground, and the top left, in this case pin 14, is power, and we call power VCC. So you'll have your ground on the bottom side there, and the top power VCC on digital chips. Now the 555 timer is not a digital chip. The 555 timer is kind of in between. It's a little bit in between. It's called a hybrid. Just like there's cars that can run on both gasoline and electricity, they're called hybrids. Well, this is not digital and it's not analog, so they call it a hybrid chip. And its pins are just like we show on our diagram. Now, since everyone has the ebook, it wouldn't hurt to blow up a couple of things off of the file that you have, and one thing I would want to blow up is the schematic. So that way I can see it real easily. And not only that, but as I'm building the circuit, what I'm going to do to make life easy is I'll cross off the wires that are already connected. And that way I'll know that I won't have to fool around with them because they're already done. So, one last thing before we get started on building. These are really helpful to have, hemostats or some kind of grippers, tweezers or something like that. I have a lot of these, they really come in handy for a lot of different reasons. There's a little joke there, but we'll skip past that. Okay, so looking at the little breadboard, we had it laid out so that we called what they labeled as X, that row along the edge of the top, we called X the hot, and we let the Y, which was the bus at the bottom edge, we let that be our ground. So let's, keep consistent with that. So just for the heck of it, for right now, I'm not going to use a red wire. I'm going to use a pico fuse, but let me put a red wire in there just to be kind of a placeholder so I know what that is. And I'll put the ground on the bottom, and then it kind of gives me a clue of where everything goes. I like to start putting my chips in. And this gap that's on the breadboard, this gap that's in the middle, separates the top working area from the bottom working area. So there's no connections from the top to the bottom. But vertically, the way that I'm holding it, vertically, all of the holes are connected vertically in each column. So in each column, they're connected vertically. They're not connected horizontally in the work area. They're only connected horizontally on the buses, on the hot bus and on our ground bus. Otherwise, like I say, we have holes that will connect vertically,
So let me pop the chip in across the gap, and that'll separate, you know, this one side of the pins from the other side. First though, I have to find my orientation mark. And I find my little orientation mark, which we said here just a minute ago is usually a semicircle, or it could be a dot. Well, in this case, it's a semicircle. And I can also, when I hold it this way with its orientation mark toward the left, I can read the numbers, NE 555. The NE is a manufacturer's number. The 555 is what we call a base number. That's our part number. So I can put it anywhere I want. There's no, you know, rhyme nor reason to where you have to put this thing. But I like to give it a couple of holes over to the from the very one side, so that way, just in case I need to run things. So I'll put it just here for the heck of it. Now when you put these in here, sometimes you have to just a little teeny bit, put a little teeny bit of pressure on these pins to just push them together slightly so that they'll fit in the breadboard. You also, it's kind of an, you know, kind of an art actually, getting these things in and out without bending up the pins, because we have a limited number of parts, so be real careful with them. So you want to go very gently. I'm going to kind of rock it in with a rocking motion using both of my fingers, and making sure that the pins are not going to get bent. Okay, there, see, and it goes in pretty nicely. If you do bend a pin, get a little pair of needle nose pliers or something like that, and very gingerly see if you could bend it back out, you know. But otherwise, we're in a big amount of trouble because we don't have backup parts. And you can order them through the websites, though. There's plenty of websites if you happen to have a problem. All right, so the first thing I do personally, I think this is a good habit to get in. I always like to connect up my power and my ground. And I don't know, I like to do that first and make sure that's out of the way and it's done properly. So most people that are in the digital class have breadboard wires. If you're in one of the other classes, you have the DuPont wires, so you could use those. Or you just use regular wires, you know, and get some at Home Depot or something like that. A very small wire. I think it's probably, oh gosh, I don't even know. I think 20 gauge. It's got to be solid, not stranded wire. And that ought to do okay. But you guys that have the breadboarding wires, makes it real simple to connect up. We're going to connect our power and our ground. So let me go ahead. The color's unfortunate. I see a red. That would mostly indicate that red would be hot, but it's the size in this case of wire. They have all the little red wires at the same size. I'm going to use that for my ground. So my ground is pin 1. So I'm going to do that right away. So bingo, there's my ground is done. And so what I'm going to do is I'm going to go ahead and I'm going to put a little X there. So the ground is done. All right, the next thing that I want to connect is the power, and the power goes to pins 8 and also to pin 4. Oh, how are we going to do that? All right, well, let's see. Well, 8's the easy one. That's straight up, so I'll do that. I'll say, okay, let me grab another one of those little red ones, and I'm going to go from pin 8. Remember, because we go 1, 2, 3, 4, and then we flip up and go 5, 6, 7, 8 toward me. So from that hole, we're going to go to the bus. That's going to have our 5 volts on it, our hot bus there. We'll push that in there. See, these are pretty helpful. And then we have to figure out, okay, from 8, how do we get to 4? It's like we got to kind of crisscross diagonally across that IC. And there's no wires that's going to do that, so just pick a small wire, and we're going to have to finagle that in there some way. So I'm going to say, okay, I have a little bend on it. I'm going to go from pin, looks like the bombing has started. So pin 8, and we're going to go over to pin 4. Right? So that's done. So you might be hearing the aircraft or C-130s, and what those are cargo aircraft, and they use them for spraying missions. They're based out of Vienna Air Reserve Base. Pretty cool. 3 of them just flew over. And let's go ahead and cross off the wires that we just connected. So we connected pin 8 and we connected pin 4. Now we have to put a 47K. Now here's something that I wanted to show you. This is out of a different book. This is a book that I wrote called Extreme Fundamentals of Technology, but you could look on the internet and find anywhere on the internet a color code chart. I like to use what's called a mnemonic, and that way I can memorize something weird, and knowing that weird saying, it's going to enable me to pick the proper color orientation of the resistors for the right amount of ohms that we want to use, and in this case a 47K. So looking at a color code chart or doing the memorization thing, 47K is going to be a yellow, violet, orange, and that has to go from hot, so that's going to be pin 8 or pin 4 or the bus, and that has to go to pin 7. So I guess I'll go right from hot to pin 7. All right, that's an easy one. So that goes right up here on the top from the hot bus to pin 7, and I'm going to mark that as being connected. Now I also have to go from that same spot through another 47K, so I grab another one of those color resistors, and I have to go to pin 2 and 6. So I have my choice, so let's see which one would be the easiest. Well, 6 is over on the top. Here's 4, 5, 6. I could do that, or I could just go right across this chip, which, by the way, we're not really supposed to cross over chips because it makes it a little difficult when you have large projects. But for this project, I'm going to go ahead and do that because it's real easy. So from pin 7, I've gone to pin 2, and now I have to connect. So that's good. Pin 2 has to go to pin 6. So I have to get kind of a little bit of a big wire and go from, I'll go around this way. Pin 2, where that resistor was just connected. Well, I'm hoping this is all coming out okay on the camera. This goes to 6. Whoops, I put it in the wrong one. So you got to always double check yourself. I have it in the wrong pin. This is supposed to go 2 to 6. Okay, so 2, wait a minute, I'm going to go back and check this first wire after, but 2 to 6. So 8, 7, 6. All right, so that one I think that's good. Yeah, so 2, pin 1, 2 to pin 5, 6. Yeah, that's where it is. Now let me check that other one that I had, that other jumper. Let's see, that was pin 4 and 8. Well, 8, yeah, and 4. Okay, that was good. All right. And we'll go ahead and say we're good for now, but we'll double check the whole thing when we're finished. So now I'm going to mark off pin 2 and 6. They're done. Okay. 5 is disconnected. Sometimes if we have issues with noise, sometimes we could connect a little capacitor from here to ground, but this seemed to work okay without needing to use it. Now I'm going to go ahead and put my output. Well, let me put the cap on here first. So I got to have the 10 microfarad cap. So that's a 10 with a little UF, 10 microfarad. And these are polarized. These capacitors have a little negative sign on them. And they also have like a smaller lead. And that tells you that that's the negative side. All right, so the other side being the positive side is where I want to go to the resistor. So that resistor connects to the capacitor, and the negative side of the capacitor connects to ground. So we're good with that. Okay. Now my output is a 220 ohm, so that's going to go on pin 3. So I find pin 3, 1, 2, 3, and I stick that anywhere from pin 3 to some spot on the board over here, and I connect up my LED, which goes to ground. And the ground on an LED is the small size line, the small wire, or I used to have problems when I was in the Air Force. You know, we used to play tricks on each other. So sometimes people would cut the wires differently and your LEDs wouldn't work, right? So don't ever play tricks like that. That could be a real problem. It could also get you a punch in the nose. But anyway, the way that I check these is if you look real carefully, you have to look really, really carefully. But one side of the plastic will be a little flattened. The flattened side of the plastic is going to also be negative. That's pretty hard to mess with. So that is either the small wire, or check it by looking for the flattening of the plastic. That's the negative, so that goes from the 220 ohm to ground. And the 220 ohm limits current so we don't burn up the LED. Looks like we're all good. All right, so now what I'm going to do, I'm going to hook up to my Arduino. So let me go ahead and bring the Arduino over here. I'm going to get rid of my red wire and put my Pico fuse in here, but what am I going to do before I actually apply power? What am I going to do? I'm going to double check everything. Double check everything. We see that it's about once a second, you know, and changing these values around, we could make it flash at different rates. And I think it'll go, I'm trying to think the highest that you could get that thing going. That's a good question. That's a good homework question, isn't it? There you go, you got something for homework. How fast can I make a 555 timer oscillate? We call this an oscillation because it's like a pendulum going from one way to the other way, you know, like an oscillating tuning fork or a spring, you know, that's oscillating. So how fast can we make the 555 flash an LED? That's your homework assignment.